Hey Evan, Elizabeth here again. I figured out your Riemann sum thingies, and I'm going to try to make this expedient because I know you have a test tomorrow, but I'm going to try not to talk too quickly. If my pacing is off, let me know, and I'll go through it more carefully, because there's always room to be careful and take more time. But I don't want this to be a super long video. Okay, so here's what I did. I've emailed you the PDF. I've written everything out already, and I've scanned it and I've emailed it to you. So what you should do in this video is see if you can write it out yourself along with me. Okay, because watching me do it is like watching somebody else ride a bike. You don't learn how to balance and do it yourself unless you are on the bike. Okay, so write this out with me, but here's the idea. Okay, these are rectangles. Okay, so sorry, it's like 1:30 in the morning and I'm a little bit tired. Let me try to say this clearly. Okay, so they give you the limit side and you have to come up with the matching integral. Okay, so let's look at this limit side. And the first thing I did was say, you know what, we've got 6 over n here and we've got 6 over n here. And let's just rewrite that so it's 6 over n times I. I know 6i over n is the same thing, but it looks better to my brain if I do this, because then I can see more clearly, hey, ding, 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 you know what? It sure looks like we're starting at the number 5, and then when I is 1, we're adding on 6 over n. When I is 2, we're adding on twice 6 over n. When I is 3, we're adding on 3 times 6 over n. And that sounds an awful lot like starting at 5, adding on a bit again, adding on a bit again, adding on a bit again. This is breaking up our x's into the ordinates as we march across our interval. But that's what I'm trying to say here. I can see it right here in the 6 over n, and I can see it right here in this brackety business times 6 over n. That's your b minus a over n. How many strips you have? We don't know the value of n. It's just divide your interval into n strips for some n. Okay, but b and a are the endpoints, and the width between them is 6. Okay, I know that the interval is 6 units wide. I hope that makes sense to you. I draw it out in detail here. Okay. I also observed that these two bits are the same, and the I increments them. I think I just said that. And this is what your interval is doing. Okay, so your first ordinate is A. I write it out again below. This is your x naught. Okay, so you start at A, and then if your interval is 6 units wide and you cut it into n strips, then each strip is 6 over n wide. Take a minute, make sure you're happy with what I'm saying. Okay, I know I'm talking a little bit quickly, so pause and think for yourself and decide if you're happy with what I'm saying. Okay, so each little strip, we've got n strips, and each little strip is 6 over n wide. Okay. And here's how we count out the ordinates. Okay, so we start at A, and then your next ordinate is add that little bit on. That's this number here. Okay, A plus 6 over n. And then you add that same on again. So this is A plus 6 over n plus 6 over n, which is twice 6 over n. Okay, and you go all the way up until, I increments you along this interval. Okay, I increments your summation terms. Okay, but you stop when you reach n. So when I equals n, you stop. So your last ordinate here, your last ordinate, which is b, okay, happens when I equals n. And so you got a plus n copies, that was your I, n copies of 6 over n. Oh, look, the n's divide out, you got a plus 6, that's your b. Yeah, your interval is 6 units apart. Pause, take your time, come to your own satisfaction on that. Okay, here's the interval labeled all out again. I hope you can see this okay. Okay, so here's your A, here's your B. Sorry, I didn't write B on that in your notes. That's your B. Okay, or X naught, that's where you start. He's not part of the incrementing story. I mean, he's not one of these guys. he's just where we start. Okay, so when I is 1, we've added on 1 bit. So this is when I is 1. X sub 1 is when I is 1. That's your next ordinate along, but you started back at your 0th ordinate. 1 more fence post then panel. Again, pause and think it through for yourself. If it doesn't make sense to you, let me know and I'll say it more slowly. Okay, so I know that we're starting at 5 because when I is 1, we're at 5 plus 6 over n. We've already added on 1 little bit, so we must have started at 5. Okay, so I equals 1. That's what we get. I equals 2, our second x ordinate. We've added on 2 little widths from 5, 3 little widths from 5 when I is 3. That's our third x ordinate. March down the line till our very last one. That's b. I forgot to write that in. Your nth ordinate, because I counts up to n. You've added on n little bits from 5. So that's the number of fence panels. Okay, and 6 plus 5, 11. I think that's really nice. Once you see what the heck the algebra is doing, I think it's very pretty. Where does this take us? Okay, so we understand that this bit is incrementing our x ordinates down the interval. Okay, so this is x. That's why this is x. Okay, and we know that we're going from 5 to 11. We just worked those endpoints out. And that was the expression for x, and that's our integral. I said here that in the summation, you have a fixed number of x's, a finite number of x's. Okay, so we list them out as 5 plus a bit, 5 plus a bit more, 5 plus a bit more again. But as we let n get stupid big, all these x's get closer and closer and closer and closer to each other. Okay, and it becomes continuous in the limit. The integral is the limit, and we're continuously going through the x's. So rather than incrementing x by x by x by x by x, we just say plain old x, some number in the continuum between 5 and 11, and the integral goes smoothly across the continuum is the idea. Okay, what I didn't say here is how the heck do I know this is a rectangle? Well, x squared minus 4x, that's the matching y value. That's the y value for a given x. I say it in the next example more clearly. Okay. Here in the summation, the i's generate an x, that's your ordinate, and then this mouthful of algebra gives you the y value. So you've got a height times your width, and that's your rectangle. That's your y value, how high up you are in your strip, and that's the width of any of the strips. Okay, so this height will change because your x's are changing, but the width of each strip is always the same. So this is a Riemann rectangle sum. Okay, I hope that unpicks this a little bit. Let's look at the other one. The other one, you start with the integral, and they want you to cough up the sum. And it looks like this was magicked out of nowhere, but you're starting at the -3. That's your x naught, your first ordinate, your first fence post, okay? And then the next fence post, you're going to add on a little bit, and then add on a little, I mean, we have to pretend we don't know that, right? We have to pretend we're starting with this. Okay, but we know we're starting at -3, okay? And we're going all the way up to 4. You should stop and write this down. I hope you're pausing as you're listening, or at least watching through a couple times. Okay, so starting at -3. Okay, your interval goes all the way up to 4. So that span, b minus a, is 7. Okay, and if you chop it into n strips, each strip is 7 over n wide. Again, draw it out for yourself. Okay, but again, let's go through it. Okay, so here's x naught, your first ordinate. Your next ordinate is -3 plus the width of a strip. Your next ordinate, your second, well, your x sub 2, I guess that's your third x value. Your x sub 2 is your add-on 2 little strip widths. That's when I equals 2, x sub I. All the way down until I goes to n, because our summation is going to go from 1 to n. That's just how they set it up. They're not going from 0 to something. They're going from 1 to n. Okay, fine. That's why this 0 is not part of the count. Count starts here, but you know, that's the end of your first strip. I know I'm speaking fast, I'm sorry. This this last strip is when I equals, sorry, this last ordinate, your letter B, is where I equals n. And again, -3 plus n strips of width 7 over n takes you to 4. So your endpoint is 4. Okay, so this business marches your x's down your interval. This -3 plus 7 over ni, we built that by saying, okay, I know how long the interval is, and I know I'm going to chop it into n strips. So each little strip is this width. So I know how to march on from -3 to get there. That's you're adding 1 copy, then you're adding 2 copies, then you're adding 3 copies, then you're adding 4 copies. You're adding I copies of it until I equals n. Pause, take a minute, be happy with how I magicked that up. Okay, so we know that our summation is going to be from I equals 1 to n of something times 7 over n, because that's our b minus a over n. That's the width of our strip. We need this to be a height. Well, that's our y value. Our height is of each rectangle is the y value for a particular x. Wait. You said the y value for a particular x. The y value for a particular x, well, this is a particular, a generic x somewhere along the way. You started at -3 and added I copies of your width, your little strip width, okay? That's an x number. If you shove that in to get a y value, then you've got this mouthful cubed -2 all square rooted, and that's how you come to here. That's a y value. Okay, so your little rectangle, here's, okay, starting at the beginning, your first ordinate up to x sub 1, that's the width. Your height is y1. How do I know it's y1? Because you're sticking x1 in first. When you're doing this, you start with I equals 1. That means you're starting with x1. So it's, I think it's a right-hand rectangle. You might just want to check that. Compare to your friends, ask Miss Eastup, but I think these are right-handed rectangles. Okay, so yeah, so just to recap what I just said to you, 1 strip, that's your base, that's your height, so that's your area. And you get those y values through sticking that xi into, because you got this from the integral they gave us, but we worked out how to increment each of those little xi's by this expression. And so that's the area of 1 strip. I feel like we're in Las Vegas. This is the area of 1 strip. And then you sum up all those little strips. You got n of them, sum up n of those little strips. Okay, and then, whoops, excuse me, you take the limit, you let n get stupid big, so you take the limit of that sucker, and that's the definition of the integral. The integral is the limit of those summations as n gets bigger and bigger and bigger. There you go. Okay, I'm going to save this and upload it to YouTube. I hope it's helpful. Let me know what you think. All right. Thanks, Evan.